Hey 7th graders, it's Mrs. Cervantes. It's 14.1 rational and irrational numbers today. Your I can statement is I can rewrite rational numbers in decimals, take square roots and cube roots, and approximate rational numbers. Alright, so let's look at your key terms. Square root, make sure you pause the video and write all of these down, and then write down our examples as well. Square root, the true definition is a number that is multiplied by itself to form a product. Let's do the square root symbol. Let me go over that first. So I'm going to do some descriptions in here. So your symbol for square root, which most of you already know, looks like this. Okay. There's not a 2 there. You'll see when we get to cube root there will be a 3 here. So cube root, the symbol would look like this. The cube root, you'd have a 3 there over your next, above your square root symbol. So the symbol, a number that is multiplied by itself to form a product. Your symbol is square root. So if I'm asking you, here's an example. If I'm asking you the square root of 4, it's asking you what number time multiplied by itself. So multiplied by itself gives you 4. So it would be 2 times 2. Okay, so the square root of 4 is 2 times 2. So the square root of 4 is equal to 2. And then let's do cube root since we're already on the square root. It's a number multiplied by itself, but this time you're doing it 3 times to form a product, okay? So if you're looking at a cube root, let's do, as an example, we could do, let's do cube root of 27. Or let me do cube root of 8. That's easier. So cube root of 8 means what number times itself 3 times gives you 8. So 2 times 2 is 4, times 2 is 8. So the cube root of 8 is also equal to 2. Okay? Now, if we're talking about perfect squares, it's a square of a whole number. So squaring something means multiplying it by itself. So your perfect squares would be 1. 1 times 1 is 1. 2 times 2 is 4. 3 times 3 is 9. 4 times 4 is 16, 5 times 5 is 25, 6 times 6 is 36, and so on. You guys get the idea. So those are your perfect squares, and number times itself, okay, and a whole number. If you're looking at perfect cubes, the same idea. 1 times 1 times 1 is 1. 3 times 3 times 3 is 27. Oh, I skipped 2, sorry. I don't know why I keep trying to skip 2. 2 times 2 is 4, times 2 is 8. 3 times 3 is 9, times 3 is 27, and so on. Okay, I won't keep going. You guys can figure those out. So there's your square root, your perfect square, your cube root, and your perfect cube. Okay? All right, let's look at the first examples. So it takes you through some review real quick. It's saying write each fraction as a decimal. If I want to write 1/4 as a decimal, most of you already know and you'll relate this to money, 4 quarters. So most of you would immediately write 0.25, okay? Another method is if you know this needs to be hundredths, or tenths. 4 can get to 100 by multiplying by 25. So you keep equivalent fractions by doing the same thing to the top. You get 25 hundredths, and how do you write 25 hundredths as a decimal? 0.25, okay? B is 1/3. A lot of you will know that this is 0.3 repeating. Okay, so if not, how do you do it the long way? You could do 3. Well, does it fit into 100, a 10? If not, you do 1 divided by 3. Do your long division. Doesn't fit. Add a decimal and some zeros. Bring your decimal up. 3 into 10 goes 3 times. That's 9. Subtract and you get 1. Bring down. So you see that the 3 keeps going. So it's 0.3 repeating. Okay? All right, let's look at write each decimal as a fraction in simplest form now. So if we're talking about place value, you've got your tenths, your hundredths, right? TEHS on the end, and your thousandths, just as a quick review. Okay, so if I have 825 is how I would read that, thousandths, it would be 825 over 1,000. And then you can look at that and say, okay, what's my common factor that I can reduce by? So I would say 25 here. So if I divide both of those by 25, if you choose a different one and you might have to reduce a couple times, that might happen. All right, so if we look at that and we divide that by 25, we're going to get 33/40ths. And then 33/40ths does not have a common factor, so then you're done with that one. Okay? Now, 0.37 repeating is a little bit different. I'm going to show you guys the trick. All right, so if you're doing 0.37 repeating, like we talked about, there's your tenths, there's your hundredths, and I'm going to show you, you would really be subtracting 1x because x equals 0.37. You would be subtracting that out, but that seems to confuse everyone. So I'm just going to show you guys the method that we typically use. If this ends in the hundredths place, so this is 37 hundredths, what you do is you take 1 away. So when it's repeating, so because it's repeating, this is a trick, you take 1 away. So it'll be 37/99. You take 1 away, so let me write it this way. So we do a -1, oops, I shouldn't do it like that because that looks like multiplication. You're going to do a -1 there, and that gives you 99. So here's how you write a repeating decimal. Let's do another one. If I was doing 0.2 repeating, this ends in the tenths place. So that would be 2, and instead of tenths, you take 1 away. It would be 2/9. Okay? If I was doing, let's do, what do we do? 99. Let's do thousandths. 452 thousandths, and we'll do that repeating. So this ends in the thousandths. So instead of being 452/1000, because it's repeating, it would be 999. Okay? So that's how you change repeating decimals to fractions. All right. Let's look at square roots. So squares and square roots. So if we're solving each equation for x, that means they want us to get x by itself. And then when we're talking about inverse operations, what's the inverse of squaring something? Let's write this. The inverse, write this in your notes, of squaring a number is square rooting the number. So just like add and subtract are inverse of each other, and multiply and divide are inverse of each other, squaring something and square rooting something are inverse of each other. So we haven't done a lot of solving equations with variables, but if I want to get x by itself, so this tells me to get x by itself. I have an x squared and I want x by itself. If I square root x squared, doesn't it mean x times x got me x squared? So the square root of x squared is x. And when you solve equations, what you do to one side, you do to the other. So if we square root 121, what number times itself gives me 121? It would be plus or minus 11. Because 11 times 11 gets me 121. And negative 11 times negative 11 also gets me a positive 121. So that's where you get this plus or minus 11. It can be positive 11 or negative 11. So the square root of 121 is positive or negative 11. So for this problem, solve each equation for x. The x has a value of positive or negative 11. Now let's do b, where there's fractions. You can actually break your fraction into two pieces. So if I square root x squared, I get x equals, and the square root of 16 is 4, and the square root of 169 is 13. So x equals plus or minus 4/13. Because again, positive 4/13 times positive 4/13 gets me 16 over 169, and negative times a negative gets me the positive 16 over 169. All right, let's do 729. If we're looking at the square root, of 729, or actually, is that one cube root? Yes, we're cubing this one. So what number times itself? So square root, cube root, right at 3. The cube root of x cubed is x, so meaning x times x times x gets you x cubed. What's the cube root of 729? So what number times itself gets me 729? That would be 9 times 9 times 9, right? So the value of, I actually shouldn't write it that way. Let me just put 19. Because if you're cube rooting x, x is equal to 9. Because, let me write it over here. 9 times 9 times 9 gets you 729. And negative 9 times negative 9 times negative 9 also gets you 729. So your answer is positive or negative 9. Okay? If you're looking at D, the cube root of x cubed is x. And then I need to cube root 8, and I need to cube root 125. For 8, 2 times 2 times 2 gets me, 2 times 2 is 4 times 2 is 8. And 5 times 5 is 25. Times 5 gives me 125. So 2 and 5. So I would have 2 and 5, and it'd be plus or minus 2/5. Okay? All right, if you need practice on those, rewind and watch them again. Or you can go online and look up cubed roots as well, and square roots. All right, so then you have your additional practice. In class, we will go over the Explore activity where we're estimating irrational numbers. So I'll show you how to estimate, and Ms. Talati will show you how to estimate square roots when it's not a perfect square or a perfect cube. All right, you guys make sure that you finish the additional practice and come in with everything ready, and I will see you tomorrow. Have a good night. Bye.